All right, let's dive right in. Today, we're talking about a programming language that could literally shape our future. It's called MeTTa, and it's being built for a world where humans and, yes, artificial general intelligence, or AGI, can finally work together, side by side. So just imagine for a second, you're trying to write the software for, I don't know, our entire global financial system. And your coding partner? It's a superintelligence that thinks a million times faster than you. That's not just a challenge, it's a whole new reality we need to prepare for. And that really is the million-dollar question, isn't it? How on earth do you collaborate with something that powerful without a catastrophic misunderstanding? I mean, think about it. One tiny little error, just a single misinterpretation in the code, and the consequences, well, they could be unimaginable. So we absolutely need a language that is provably safe and crystal clear to both of us. And that, right there, is where MeTTa comes into the picture. The people building it believe it's the answer to that very big, very important question. To put it simply, MeTTa is being built to be that shared language, the common ground where humans and an AGI can meet to literally write the rules for the AGI's own behavior. It's not just another programming language, it's really a framework for one of the most important collaborations in history.
And you should know, this is not some fringe idea cooked up in a garage. Nope. MeTTa is a key piece of major AI research initiatives like the OpenCog and Hyperon projects. It's born from a collaboration between some heavy hitters in the space, like SingularityNet and F1R3 Fly.
Okay, so to really get our heads around what makes MeTTa so special, we're going to need an analogy. Because let's be real, some of these concepts get pretty abstract. But trust me, if we frame it in a way we all understand, it'll all just click. So for the next few minutes, I want you to picture a global air traffic control system. Every plane, every airport, all connected. This one idea, it's going to be our key to unlocking how all of this works. All right, our first technical term is operational semantics. In the world of computer science, this is basically the rock-solid mathematical rulebook for a language. It leaves zero room for guessing or ambiguity. It's pure logic. But in our analogy, it's way simpler. Just think of operational semantics as the international flight laws. It's that single, universal rulebook that every single pilot and every single control tower on the planet follows, right down to the letter. No exceptions. It's the system that keeps the whole thing safe. Okay, next up, the algebra of states. Now, I know that sounds complicated, but it's just the formal grammar that can describe the complete picture of the entire system at one single, precise instant. And our analogy makes this super simple. The algebra of states? It's that giant radar screen in the control tower. It gives you a perfect, frozen snapshot, like a photograph, of where every single plane is in the sky at this exact moment. Now, what's really cool is how MeTTa's radar screen is organized. It's not just one big mess of data. It's neatly separated into 4 distinct parts. You have the input, the knowledge base, which is kind of like the system's long-term memory, the workspace, where all the active thinking is happening, and finally, the output. So, if the state is a snapshot in time, how do we get from one snapshot to the next? Well, that's where rewrite rules come into play. These are the specific instructions for making a change. And yep, back in our control tower, these are the actual commands the controller says into the radio. Flight 734, descend to 10,000 feet. Every single one of those commands is a rewrite rule, and its job is to guide a plane safely from its position in one snapshot to its new position in the next. So you might be asking, why design it this way? Well, it's all about finding a balance. On one end, you have these very pure, very simple models where the code and the data are the exact same thing. They're elegant, for sure, but not always practical. On the other end, you've got these massive, complex beasts like the Java virtual machine. MeTTa is trying to hit that sweet spot right in the middle, balancing that formal simplicity with real-world power by letting its code interact with an external state, like that knowledge base we were just talking about. Okay, so we've got the what and the how, but why? Why go to all this trouble to create such a formal, rule-based system? Why does this all matter so much? At the end of the day, the goal is to create a universal standard, a blueprint. It's just like how the Java virtual machine specification makes sure that Java code can run on any machine. The MeTTa specification is meant to do the same thing, ensuring that anyone, anywhere in the world, can build a component that plugs into the AGI ecosystem perfectly and safely. And having this strict, universal rulebook unlocks some huge advantages.
First off, you get what's called correct by construction design. This means safety isn't something you tack on at the end, it's baked into the system from the very beginning. Then there's decentralized development. Because everyone's building to the exact same spec, teams all over the world can contribute without breaking things. And this means no single company or government can control it all. You can also mathematically prove that two different systems do the exact same thing. That's called bisimulation. It's all about building a trustworthy, transparent, and global foundation for what might just be the most important software humanity ever writes.
And here's where it gets really mind-bending. The design of MeTTa isn't just about safety and collaboration for us. Right now, it's about what the language itself can become in the future. This all comes down to a wild concept called meta circular evaluation. And what it means is that MeTTa is designed to be able to describe its own rules, its own instruction manual using the meta language itself. It can talk about itself.
So what's the point of that? Well, it creates a language that is, in a very real sense, self-aware. It can do incredible things like check its own programs for errors, run simulations to find bugs, or even reflect on and reason about its own fundamental structure.
And that right there leads to the ultimate vision. See, the end game isn't for humans to be perfecting MeTTa forever. No way. The goal is to build a foundation so solid that future AGIs can actually take over, using MeTTa to model, adapt, and evolve their own language at speeds that we can't even begin to imagine. And that leaves us with one last, pretty profound question to think about. What happens when our tools become intelligent? What happens when a language, the very foundation of our logic, is smart enough to rewrite its own rules? That's the future MeTTa is being built for. Thanks for joining us.